Hello everyone. Today I'm going to discuss the last problem of Leetcode Weekly contest 439, which is lexicographically smallest generated string. So what is the problem? We are given two strings str1 and str2. A string word of length n plus m minus 1 is defined to be generated by str1 and str2 as follows. So let me take one example to make you understand it better. So let's take the first sample only, tf and ab. So TF and ABAB is our first sample, where S is TF and TF and our P, what str2 is AB. So we have to generate a string of length 6 because length of this is 4 and length of this is 2. So we have to generate a string of 4 plus 2 minus 1, length 5 substring, length of string. Okay, and what are the properties of the string? Let's say this is a length 5 string. Okay, length 5 string. So this first character is P. That means that the substring of length 2 starting from this index in word should be AB. So we can fix this AB. Now this if means that this substring of length 2 starting from this B index should not be AB. Okay. Now for the third T, that this should also be AB. Okay. The substring starting from three index 3 and length 2 should be AB, and for F we don't know. Okay. Now so lexicographically smallest string will be if we put A here. Okay, if we put A here, then this will be our lexicographically smallest string, also obeying all the conditions. Okay, now how we can solve this problem? This problem is quite straightforward and I don't think it is of level D of a lead code contest. Why? I will explain you. Because this problem could be solved in brute force way. Okay, so what my solution approach, I will directly come to solution approach. First let's discuss the time complexity that could be possible. Okay, so n is 10 to the power 4 and m is 500. So we can say that order of nm is possible, order of nm is possible. Also another time complexity involving string should be 26. If we multiply 26 into n into m, this is also possible, I think. Yeah, this will be 10 to the power 6. Yeah, this will also be possible. 26 into n into m is also possible. Now how we will solve this problem? First we'll just fill out all the values where there is a t. Okay, so let's say our let's take one example. Okay, let me write it here. Let's say our ace is, let's say fft fft, and our string is, let's say this is cd. Okay, now ff means what will be the length of the word? The length of the word will be 6 and 2, so the length of the word will be 7. Okay, so 6 plus 2 minus 1 will be 7. So let's create an empty string, or we can add 7 hashes. Okay, 3 4 5 6 7. Okay, initially everything is 7. Now hashes. Okay, now we will just replace all the values where there is a t. Okay, so if we use zero based indexing, at the second index there is a t. Okay, so we have to replace from the second index two values cd. Okay, now the last value is also a t. Okay, that means 0 1 2 3 uh, 4 5. Okay, so 0 1 2 3, two hashes, and there will be I think hash cd hash, and this will be cd. Okay, so this is completed. Okay, hashes cd hash cd, we have generated the string. Now what will we do? We'll try to put in the hashes, we will try to put every value from a to 6 a to z. Okay, so we'll try to put a, and if it is possible, if we put a and all the conditions are satisfied, then we can add a here. Okay, we can add a here. After that we'll try to put a in the second condition as well. Then we'll ignore which is already the indexes which are already filled. So a c d will be there. Now a c d will be our answer. So the problem is quite straightforward. We'll go to every empty index which is not filled yet, and we'll try to put every index from a to z, every character from a to z. I mean, if it is obeying all the conditions, then we'll just add it. Okay, now let's jump to the code, because the solution is this only. This is quite straightforward. So let's jump into the code. Here I am initializing answer with all hashes. Now I am putting the character say equals to t, then I am putting p to all the indexes. I hope you get it. So if this is t, then we'll put this into all indexes. Now there is a catch here. Okay, there is a catch here. whenever, let's say, there are back to back two indexes where there is true, but it it is also possible that there should not be a case where back to back two indexes is true. Okay, let's say something like, we have something like, I think, I'm not fully sure if this is the case. Let's say P is CD and our, let's say, this is TT. Okay, then this is not possible, right? So we'll just put CD here, but the second index should also be true. But any if we start from D, it is not possible to get P. So this is not the case. Okay, so if P equals to CD and A is equals to TT, the string is not possible. So we have to check before putting. If we have to check if answer I plus j is already filled. Okay, answer I plus j is already filled and it is not equals to the current character what we are going to put, then we just return empty string. Empty string means that this is not possible, otherwise we will assign the character. Okay, now this part is for assigning only true cases. Okay, that's I have already explained here, assigning only true cases like this. The string after doing this operation will be like this only, hash cd hash cd. Now we'll iterate over all the character in the answer string. Now if answer I is hash, that means that this character is not filled, right? Now we'll try to put every character from A to Z. Now at the first we will do answer equals I equals to j plus j, right? That means we are adding this jth character to uh, ith index of answer. Now if we'll initialize flag as 0, now we'll check all the possible substring, all the possible substring, two-length substring. So let's say we are trying to put a value here. Okay, here in this first index, zero based indexing. First index we will try to put A. Then what are the impacts? The possible impacts will be like this or this. Okay, so we'll try to check every substring uh, that is getting impacted by changing this character. So k is maximum of I minus m plus 1 0 and k should be minimum of I comma n minus 1. Now if sk is t, that means we have already checked. I don't think this condition is necessary, but you can still do this. If sk is t, we'll just continue. Otherwise, if k plus m is less than equals to n minus 1, I think this condition is also not necessary because we have just limited k here, and the substring is equals to p, but we know that s of k is false and the substring is equals to p, that means this is not a valid case, so we are marking flag as 1. Now if at any index the flag is 1, that means the if we set the jth character to the ith index, the answer is not possible. So only if flag equals to 0 we are breaking. If flag equals to 1, we will try the next character. Okay, now at the end what we will do, at the end we will just verify all the conditions again. Okay, so this is just a safety check, right? We'll just verify all the conditions. I don't think it is necessary, but I have just done a safety check. Okay, if every condition is satisfied, then we'll just return the answer, otherwise we'll return the empty string. So this problem is quite straightforward. I think there will be challenges if we try to reduce the time complexity, but according to the constants, nm into 26 is also acceptable. So I have not overthink about the solution. Okay, if you have any doubt in any part of the code or explanation, you can always ask in the comment section. I'll try to reply each and every comment. If you find this video helpful, please like the video, subscribe to the channel, and also share among your peers. Thank you.